There are no fuse clip reducers available to use smaller fuses in larger fuse clips. To use FRS R20 of fuses with the 460-volt, three-phase disconnect designed for FRS R40 through FRS R60 of fuses, you have a few options. Firstly, replace the existing fuse clips with ones designed for FRS R20 of fuses. Secondly, use fuse reducers that fit inside the FRS R40 through FRS R60 of fuse clips and allow you to insert FRS R20 of fuses. However, note that fuse reducers may not be as reliable as standard fuse clips. It is important to ensure that the fuse reducers or replacement fuse clips meet the requirements of the National Electrical Code, or NEC, and any local building codes. The fuses protecting the equipment should be coordinated with the feeder fuses, which are 60 amps in this case, to provide proper overcurrent protection. Always work with electrical equipment with qualified personnel and follow proper safety precautions. Thinking about this further, let's delve into some additional considerations when dealing with fuse clip replacements and fuse reducers. When considering replacing the fuse clips, it's crucial to select clips that are specifically designed for FRS R20 of fuses and are rated for the voltage and current requirements of the system, which is 460 volts in this case. The new fuse clip should be made of a suitable material such as copper or a copper alloy to ensure good electrical conductivity and corrosion resistance. The installation process should be carried out by a qualified electrician who can properly disconnect the power, remove the existing clips, and securely install the new ones. It's essential to ensure that the new clips are properly aligned and tightened to provide a reliable electrical connection. Furthermore, verify that the disconnect enclosure has sufficient space and mounting provisions for the new fuse clips. If the enclosure is too small or lacks the necessary mounting points, modifications may be required or a different disconnect may need to be selected. When considering fuse reducers, it's important to understand their limitations and potential drawbacks. Fuse reducers are typically designed to adapt larger fuse clips to accommodate smaller fuses, but they may introduce additional resistance into the circuit, which can lead to heat generation and reduced reliability. The reducers should be made of a high-quality material that can withstand the voltage and current requirements of the system. They should also be properly sized to ensure a snug fit between the fuse and the fuse clip. When installing fuse reducers, it's crucial to follow the manufacturer's instructions carefully. Ensure that the reducers are fully seated in the fuse clips and that the fuses are properly inserted into the reducers. Regularly inspect the reducers for signs of damage or corrosion and replace them as needed. It's also important to note that some electrical codes may restrict or prohibit the use of fuse reducers in certain applications. Therefore, it's essential to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations. Fuse coordination is another critical aspect to consider when selecting and installing fuses. Fuse coordination involves selecting fuses that are sized and rated to protect the electrical equipment and conductors in a circuit while also ensuring that the fuses will trip selectively in the event of an overcurrent or short circuit. In other words, the fuse closest to the fault should trip first while the upstream fuses remain intact to maintain power to the rest of the circuit. To achieve proper fuse coordination, it's necessary to consider the characteristics of the fuses, such as their current carrying capacity, interrupting rating, and time current curves. The time current curve shows the amount of time it takes for a fuse to trip at different levels of overcurrent. By comparing the time current curves of different fuses, it's possible to determine which fuse will trip first under various fault conditions. In the case of a 460-volt three-phase disconnect protected by 60-amp fuses, the FRS R20 of fuses protecting the equipment should be selected to trip before the 60-amp fuses in the event of an overcurrent. This can be achieved by selecting FRS R20 of fuses with a lower current rating and a faster tripping time than the 60-amp fuses. It's also important to consider the inrush current of the equipment being protected by the FRS R20 of fuses. Inrush current is the high surge of current that occurs when electrical equipment is first turned on. If the FRS R20 fuses are not sized to withstand the inrush current, they may trip unnecessarily, causing nuisance outages. To avoid nuisance tripping, it may be necessary to use time delay fuses, which are designed to withstand short duration overloads without tripping. Time delay fuses have a longer time current curve than standard fuses, allowing them to ride through temporary overloads. In addition to fuse coordination, it's also important to consider the interrupting rating of the fuses. The interrupting rating is the maximum amount of fault current that a fuse can safely interrupt without failing. The interrupting rating of the fuses should be equal to or greater than the available fault current at the point of installation. The available fault current can be determined by performing a fault current study, which involves calculating the amount of current that would flow in the event of a short circuit. If the interrupting rating of the fuses is less than the available fault current, the fuses may explode or rupture during a fault, posing a safety hazard. Therefore, it's essential to select fuses with an appropriate interrupting rating to ensure safe operation. Finally, always remember to prioritize safety when working with electrical equipment. To energize the circuit before working on any electrical components. Use appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. If you are not qualified to work on electrical equipment, consult with a licensed electrician. Furthermore, always follow the manufacturer's instructions when installing or replacing fuses. Using the wrong type of fuse or installing it incorrectly can create a safety hazard. Remember that electrical work can be dangerous if not performed properly. Prioritize safety and consult with qualified personnel to ensure that the installation is performed correctly and safely. Fuse selection involves more than just matching the voltage and current ratings. It involves understanding the specific application, the characteristics of the electrical equipment being protected, and the coordination with other protective devices in the circuit. Let's consider some specific examples to illustrate these principles. Suppose you are protecting a motor with FRS R20 fuses. Motors typically have a high inrush current when they start up, which can cause fuses to trip unnecessarily. To avoid this, you might choose a time delay fuse such as a Bussmann FRN R-20, which is designed to withstand temporary overloads. The FRN R-20 fuse has a longer time current curve than a standard FRS R20 fuse, allowing it to ride through the motor's inrush current without tripping. However, it's important to ensure that the time delay fuse still provides adequate protection against sustained overloads and short circuits. You would need to consult the motor's nameplate data and the relevant electrical codes to determine the appropriate fuse size and type. Another example is protecting a sensitive electronic device with FRS R20 fuses. Electronic devices are often susceptible to damage from voltage surges and transients. In this case, you might choose a fuse with a fast-acting characteristic to quickly interrupt the current flow in the event of a surge. A fast-acting fuse, such as a Bussmann FNQ-R-20, has a shorter time current curve than a standard FRS R20 fuse, providing faster protection against overcurrents. However, it's important to ensure that the fast-acting fuse is not too sensitive, as it could trip unnecessarily due to normal fluctuations in the electronic device's current draw. You would need to carefully consider the device's operating characteristics and the potential for voltage surges to select the appropriate fuse. In addition to selecting the right type of fuse, it's also important to properly size the fuse for the application. The fuse size should be based on the ampacity of the conductors being protected and the load requirements of the equipment being served. The ampacity of a conductor is the maximum amount of current that it can safely carry without overheating. The National Electrical Code, or NEC, provides tables that specify the ampacity of different types of conductors based on their size, insulation type, and installation method. For example, Table 310.15b16 in the NEC provides ampacity ratings for copper conductors with different insulation types. To determine the appropriate fuse size, you would first determine the ampacity of the conductors being protected. Then, you would select a fuse with a current rating that is equal to or less than the conductor ampacity. However, it's also important to consider the load requirements of the equipment being served. The fuse should be sized to carry the equipment's normal operating current without tripping, but it should also be small enough to provide protection against overloads and short circuits. The NEC provides guidelines for sizing fuses for different types of equipment, such as motors, transformers, and lighting circuits. For example, Section 430.52 of the NEC provides rules for sizing fuses for motor circuits. The fuse size should be based on the motor's full load current rating and the type of motor. In some cases, the NEC may allow the use of fuses with a higher current rating than the conductor ampacity, but only under specific conditions. These exceptions are intended to allow for the motor's inrush current and other temporary overloads. However, it's important to carefully consider the potential risks of using oversized fuses, as they may not provide adequate protection against overloads and short circuits. Therefore, it's always best to consult with a qualified electrician or electrical engineer to determine the appropriate fuse size for a particular application. Fuse selection and sizing are complex tasks that require a thorough understanding of electrical principles, codes, and standards. It's important to consider all of the relevant factors to ensure that the fuses provide adequate protection for the electrical equipment and conductors while also minimizing the risk of nuisance tripping. Let's also discuss the importance of regular fuse maintenance and inspection. Fuses are often overlooked, but they are critical components of an electrical system that require periodic attention. Over time, fuses can degrade due to age, heat, and corrosion. This can lead to reduced performance and increased risk of failure. Therefore, it's important to establish a regular fuse maintenance program to ensure that the fuses are in good condition and functioning properly. The fuse maintenance program should include regular inspections of the fuses and fuse holders. The fuses should be visually inspected for signs of damage, such as cracks, discoloration, or corrosion. The fuse holders should be inspected for signs of overheating, loose connections, or corrosion. Any damaged or corroded fuses or fuse holders should be replaced immediately. The frequency of fuse inspection should be based on the operating environment and the criticality of the electrical system. In harsh environments, such as those with high temperatures, humidity, or vibration, the fuses may need to be inspected more frequently. Critical electrical systems, such as those that supply power to essential equipment or life safety systems, should also be inspected more frequently. In addition to visual inspections, it's also important to periodically test the fuses to ensure that they are functioning properly. This can be done using a fuse tester, which is a device that applies a small current to the fuse to verify that it is intact. If the fuse tester indicates that the fuse is open or has a high resistance, the fuse should be replaced. It's also important to keep a record of all fuse inspections and tests. This record should include the date of the inspection, the results of the inspection, and any actions taken, such as replacing fuses or fuse holders. This record can be used to track the performance of the fuses over time and to identify any potential problems. Furthermore, it's important to ensure that spare fuses are readily available in case of a failure. The spare fuses should be of the correct type and size for the application. They should also be stored in a dry, clean place to prevent corrosion and damage. When replacing a fuse, it's important to follow the manufacturer's instructions carefully. Ensure that the circuit is de-energized before removing the old fuse and installing the new fuse. Use the proper tools and techniques to avoid damaging the fuse or the fuse holder. Finally, always remember to prioritize safety when working with electrical equipment. De-energize the circuit before working on any electrical components. Use appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. If you are not qualified to work on electrical equipment, consult with a licensed electrician. Fuse maintenance and inspection are essential tasks that can help to ensure the reliable and safe operation of electrical systems. By establishing a regular fuse maintenance program, you can prevent fuse failures, reduce downtime, and improve the overall safety of your electrical system. In summary, when dealing with a situation where you want to use FRS R20 fuses in a 460-volt, 3-phase disconnect designed for larger fuses, remember these key points. Firstly, there are no fuse clip reducers that allow you to directly adapt larger fuse clips to accommodate smaller fuses. Secondly, your options include replacing the existing fuse clips with ones designed for FRS R20 fuses or using fuse reducers. If you choose fuse reducers, be aware that they may not be as reliable as standard fuse clips. Thirdly, Always ensure that any fuse reducers or replacement fuse clips meet the requirements of the National Electrical Code and any local building codes. This is crucial for safety and compliance. Fourthly, coordinate the fuses protecting the equipment with the feeder fuses, which are 60 amps in this case, to provide proper overcurrent protection. Fuse coordination ensures that the correct fuse trips under fault conditions, protecting equipment and preventing widespread outages. Fifthly, always prioritize safety. Work with qualified personnel and follow proper safety precautions when dealing with electrical equipment. This includes energizing circuits before working on them and using appropriate personal protective equipment. By following these guidelines, you can safely and effectively use FRS R20 fuses in your 460-volt, 3-phase disconnect. Remember to consult with a qualified electrician or electrical engineer if you have any questions or concerns.